Hello, in this video I will be doing some silkscreen printing. This is just an experiment because I want to use these very cheap UV curing inks. They are really the worst, but since I have improved my PCB production to quite nice quality, I would say, like, this is pretty fine. However, it is boring, like it is missing something, and this really bugged me a little bit. So the only thing that is missing there really is silkscreen. So I guess there is only one way to solve this, and that is to develop a capability of making silkscreen. So I was thinking about using traditional screen printing process, but for low volume production it doesn't really make sense. Like it's just too much work. So the second best option is laser plotter, but I did not have any laser plotter. Recently I've made a video about this like plastic slidey things that go on these rails, and so a guy commented there like, why don't you buy a cheap like sets from China? And I was like, well, yeah, let's have a look at how cheap they are really. And so I found a bunch of these. I probably bought from here, maybe. I think I bought something like this. Yeah, no, probably it was a little bit cheaper still. So, and this ships from Germany if you look here. And so, yeah, this is great. However, I ordered this like a week ago, and I guess I'm impatient because I have ordered these belts as well, and this laser pointer. And the rails are still not here, but I've built this machine in like 20 hours or something like that. This is including the motion control software, because oh my god, don't get me even started. So I asked AI, hey, what would you do? So, okay, there is this GRBL software, or Gerbil my balls. Anyway, so this stuff is not built for 32U4 chips. Or actually it is, but then there is no documentation. So, okay, am I going to reverse engineer this project so I can fucking build my machine? No, fuck that. So, okay, let's go find other solutions. So, okay, there's a bunch of solutions for all sorts of boards, like Arduinos, fucking Raspberry Picos, and whatever. No, don't touch lens. And yeah, nothing for 32U4 chip. So, okay, fuck that shit. I'm going to write I'm not going to write it. I was like, hey, please write this thing. Okay, so it wrote something. The thing did not work, like I don't know, anyway, so I did some manual cleanup, and now I can actually have some motion control that works. Then I have printed this holder. This is just internals from these laser pointers. There is just a buck converter and MOSFET that turns this thing on and off. So really nothing fancy. I found that I need to cool this laser diode, so I would need to like pull it out from this plastic stuff and make this thing out of aluminium probably to actually use this machine. But I found that if you drop a few drops of ethanol there, that does provide good enough cooling for testing at least, so that's fine. Other than that, the guy was probably right. These plastic things, they are perfect for x-axis, which is this one. Like this is absolutely solid, but here the y-axis, there is a little tiny bit of wobble. Like if I move this back and forth, you can maybe see it, like this side moves, this side does not. But also I had to shim this with paper because the wood is not perfectly straight, so using wood on these projects is not really great option. But anyway, I have basically used stuff that I have laying around, and I did not really have to order that much stuff to make this. And I think if I would put this belt on this side as well, I would eliminate the wobble entirely, so it's like solvable problem even with these plastic things. But this was just quick and dirty prototype, and I would have to do a bunch of stuff to make that work. But anyway, so we have everything set up. then the question is about like laser, because right now what I'm doing, basically you need to defocus the laser so you can like define the diameter of your tool, quote unquote. And right now it is set up to be burning this material basically. So if I do this, you should be able to see something on the board. And so this is Positiv 20 photoresist for PCBs, but I found that it provides quite nice contrast on the burnt like areas, and I can basically, and in order to not waste it too much, you get some ethanol and you wipe it on, and when this dries up you can burn the thing again. However, you have to be like kinda sorta careful about how you do this, because yeah, anyway, you can basically scrub it off too much and then it is pain to reset the layer. So anyway, I need to strip this off again, and I will do some demonstration about how this testing stage works, I guess. I'm stripping this with sodium hydroxide because the burnt areas are not so easy to like remove, but this board probably wasn't too bad. Now, because this was supposed to be a quick and dirty test, I have not even made board for electronics. This is basically a sockets plugged into the drivers and then into Arduino via cables. So it is what it is. It is a little bit dangerous because this can short 12 volts to something, but we will manage, I guess. Also, I have ordered 0.9 degree stepper motors because these drivers do have microstepping, but I don't trust microstepping really that much. Like it's like weird. Okay, so I have board fresh, literally out of oven, and this also works. It is supposed to stream the commands on the terminal as I run them, but it's Windows, so it doesn't like to do that anyway. This machine obviously does not have any like stop switches, so I aligned it basically like just this, and there is tape that like marks the home position. So I do this pretty much and make it run. So I will manually home it by resetting the Arduino. I plug the power. I will need to prepare the coolant for the laser. Let me actually drop a bunch of ethanol in there. Yeah, so I was doing this. Anyway, so let's start a little bit more complicated board than what I was using, but not much though. Alrighty. I've also fixed the rapid moves because post-processors. Man, I was dealing with post-processor for 4-axis Heidenhain machine or 5-axis or whatever it is. Yeah, it was 5-axis Heidenhain machine, and like I already forgot everything about how this works, but I quickly got into it back. So I saw quite a bit of axis wobble. The x-axis did like misalign this way, and so bunch of characters could be like not nice. Let's zoom in a little bit. Oh, we cannot zoom a bit. I mean, these characters are mostly readable, even though... yeah, this is C52. This is Q3, I think. R7. Yeah, it's readable, but it's not great. But here you can see this misalignment quite clearly, so... Yeah, like, rectangles are quite nice, but... yeah, there are things to be improved. This should have been circle. It's quite squashed. And I would expect on this side things to be better than say on this side. So this is like... yeah, this is a little bit... what the fuck? Okay, so it is what it is, but there were some chunks, so I was like, okay, this will be enough for first test. So let's align this somehow with 0, roughly, and... I will run special circle test that is basically just a bunch of circles. So let's see what that does. Okay, so this did not burn. I can definitely see the exposed part. Right now I want to test what happens if I let this run twice in a row. So... alrighty, so let's get some isopropanol here and try to wash this up. This will probably require some brush. Yeah, this is not adhered well at all. And the uniformness is non-existent, so I suspect that the text would be a bunch of blobs here. And only like straight lines would be relatively good, but this is not even relatively good, this is just bad. So the obvious solution is lower power, probably. Okay, so laser power. This is about 1/5 of the power, and I mean, it is quite wide beam. At full power, this was burning this plastic. Now it is not burning it for whatever reason, but with this small power I'm confident that I will need a bunch of passes, so I'm not sure if this is a great idea, but again, we'll see. You know what, this is much more consistent. Question is it durable? And I don't think it will be much durable at this point. Let me try to dry it. If I can get consistency, I would be fine with this. And what I'm going to do now is blast this with UV, with my PCB exposure box, so that's pretty high power. And then I will, you know what, let's try to break this from this side. You know what, it's good. This is much thicker, obviously, and I think that the... and I have been able to damage this, so maybe the thickness is playing against us in a way that we can easily like pry on it and produce way too much force, but Again, I will be blasting this with UV, a lot of UV, and then I will try mechanical strength again. I have pumped about 2.5 kilojoules of UV energy into this board. Mind you, bunch of have reflected probably, but still, it's a lot of power. And you know what? This seems good. Yeah, this seems good. Like I can definitely damage it, but this is pretty good. Now question is which one? I think this one is more realistic in a sense that well, how would I explain this? The line thickness is more correct, I think. Alrighty, plans have changed. I have made a mask for this, that's fine, but and because this has holes already made, I will be using paint roller to avoid putting too much ink into the holes. I know that this works because I have tried it, so let me do that. Oh boy, the sun is coming so very quickly. I need to do this finally. The big reveal. As I said, I'm running out of alcohol, so it is this or nothing. Yeah, the adhesion though is shit. Not sure what's wrong with this. Maybe if I wouldn't mechanically fucking do stuff to it, maybe it would be better, but like this isn't really going anyway or anywhere. Yeah. Or maybe it's the substrate. No, the substrate is the same. Oh, well. So I had to work, but I have a bit more energy to do one more experiment, I guess, so let's do it. Yeah, let's do it. I've increased the laser power 2 times. It is still not at full power. I kinda sorta am afraid to let it go full power, but the ink thickness is much smaller than it was before, so maybe this will be okay to run it at full power. I have no idea. Let's do this anyway. Something seems wrong about the laser, because this should be full power. Let me shine it here. Yeah, it is much brighter than what is there. So I'm looking at laser and the temperatures there are 40 degrees, which is not too hot, not too cold though, so not sure what happened there, but I mean, anyway, if I want to use this machine really, I would probably buy a laser diode like from reputable source and not something that degrades itself and disintegrates after some time of use. Well, anyway. Okay, so the laser is kaput. I did run it like 6 cycles or something like that, but I think this will fail again. So if we are faced with failure, how about we try another experiment? Let's try to use a bit less slimy solvent, and that is acetone. I mean, I am running out of alcohol anyway, so this better do work much better. And it indeed does. However, it completely lifted the cured resin from the board, so... Have I mentioned that I'm impatient? So it's still the same day, I have installed new laser. I mean, it was pretty simple. Well, I tried to press it out with drill press, and I cracked some plastic, so instead I dremeled the aluminum body. Yeah, I think this will work. Well, maybe a little bit too much. This is burning. Oh, I think I forgot to save the program. Oh, wait. Anyway, let it run. Now it should be at ultra low power. Yeah, that kinda sorta checks out. And by the way, guess what have arrived? Linear rails. So now checking the temperature just to be sure. And this seems to be pretty good. This is just 20 degrees. The bloody MOSFET is hotter for some reason. Wait, actually this is not MOSFET. Or is it? Maybe it's MOSFET, maybe it's the regulator. But anyway, you can also barely see the laser moving on the board. You know what, now I have just realized that this is not what I wanted to do. I wanted to connect drain of the MOSFET to the actual output side of this buck converter, because I don't know these converters. Like, in theory they should start from 0 and ramp their voltage up, so, and they should not overshoot too much. We'll fix that tomorrow, definitely. I'm not going to do any more changes today. As you can see, the lines are very thick and the alignment is off quite a bit. But it's consistently off, so I just need to shift my 0 somewhere else, I guess. Well, the acetone cleaned it up a little bit, but you see that this line here, this is going into the copper track, so yeah, the alignment is absolutely off. So it's a new day and I've spent quite a bit of time on cleaning the silkscreen out of this board. You can see that it wasn't too successful. However, that is kinda good, because that's what we want, kinda sorta. I've done more experiments for feeds and speeds and have found something. Unfortunately, this new laser module is not that great. Like, it has the beam quality is just too poor to focus it into the very nice spot, so this is not great. I mean, it is readable. Like, if you squint your eyes, you can see that this is 3K3, this is 10 micro, and this is 4 times 10K. Again, the alignment is somehow screwed up, so what the fuck. But anyway, did I mention that I'm impatient? So I could have ordered better quality laser, but instead I have added this 2mm pinhole, I think, to the center of this lens. Hell yeah, this is much cleaner. Even though still it is well, I say cleaner, but if you compare these two lines, they are not that different and adhesion is much poorer. Still, I should clean this with ethanol instead of acetone, because Jesus fucking Christ, cats. Because I feel like the acetone removes quite a bit of juices that are providing stiction. So, and this font size is same as this one, so you can see how much less resolution I do get actually. So there are a few things more to do. First of all, I think this thickness of this layer is quite thick. It is at least 50 microns, so I mean, at these heights, the diffusion of laser light into the surrounding areas is not too great concern, but also, if I can make this thinner, it would be mechanically more resistant. It would be like there will be lots of advantages to that. So I will order screen printing textile so I can squeegee the thing onto the board and basically remove the roller process. But really there's not much else to do than make new board and see how it goes. I don't think I will be doing it in this video because there will be, oh my god, too much editing already. So anyway, see ya sometimes later. So I did not plan on making this video, but screen printing fabric came. This is 1 meter. It cost me around $20 or 500 crowns in local currency. This is insanely expensive but very high quality product. This reminds me of shower curtains, so you know, do with this information whatever you want. So I tried this. First I applied the ink over the screen, then I do the thing with laser, and it was still not great. So I did a thickness measurement. Yeah, still too thick. Okay, so what do you do? So first of all, I would probably like to order new screen. I don't really want to do that, again because it's expensive, and again because I will probably get it wrong. Well, I just dissolved some ink in acetone and applied that. I did a bunch more changes. I applied the ink, let the acetone evaporate a little bit, lift the screen, and I put this into oven at 90 degrees for about 10 minutes. So after that the screen was the ink was not as shiny. It was matte. However, immediately you can see that the text is much more readable, the lines are thinner, the adhesion is amazing. Like on the plain PCB I was never able to achieve this much adhesion. And also this was my file system got corrupted because I pulled out when I should not have. Anyway, so the program stalled and this was the result. So there is definitely evidence that when with the slow speed the curing spreads out basically, but the adhesion is amazing. This is only one pass, so that's pretty good. I read somewhere that when you bake these inks, the adhesion is much better, but I did not expect this much better. So this is all amazing data, and so I'm looking forward to doing more experiments. Not in this video, this was already way too much, but evidence that this is viable process. So see ya.